Hello, the purpose of this video is to demonstrate the use of SPSS software for establishing the statistical validity of the survey that I had conducted. This is the survey questionnaire and it had around 11 inputs and they were structured this way. So we'll get a more clearer view here. So here we can see this is the first question, second question, related attributes. Okay, likewise, 8 questions are there apart from the personal details. So these questions I have formed into constructs like the question one, scope for lean and enablers for lean. Behavioral enablers I have clubbed as first construct, then behavioral disablers I have clubbed as the second construct, then organizational enablers third construct this way. Okay, and when we do the analysis from SPSS, the values which we get from the analysis are tabulated here. So for each construct, we need to find the Cronbach's alpha, and from factor analysis, we'll get the values of determinant, KMO, p-value, commonalities, eigenvalue, and the variation. And these are the acceptable values. So if the values fall above these, then the questionnaire, the formation of the questionnaire is valid, and the responses which we get are statistically significant. So, now going with the survey response. So this is the survey response. Around 82 responses I have received. So the responses, 82 responses are there, and these responses are in the Likert scale. I strongly agree, agree, neutral, disagree, and strongly disagree. So we need to convert this to 5, 4, 3, 2, 1 for statistical analysis. So by putting it as control F, then we can put strongly agree here and put 5 and replace it. Then we'll get strongly agree replaced with 5. To begin with, we have to go in the variable view, and here we have to put the first variable. First variable is lean scope. So we take this variable, paste it here. Then you tab, go ahead. You can put the label as same thing. Then in the measure, we can put it as nominal, and the values you can define for value 5. You can put it as strongly agree. Then 4 agree. This way we can put it and save. So here I have already done it. So you can see it here. Strongly agree, strongly disagree, disagree. So 5 is the strongly agree. So this was just for demonstration. I'll delete this. And once we put in all the variables, so starting from lean scope, put all the variables. and then go to the data view. So in data view, we can paste the 82 responses which we have got directly from here. So you convert this into numeric. So here they are already converted. So just copy it and paste it here. So once we have the data, then we have to go for the Cronbach's alpha and then factor analysis to find all these values. Factor analysis has two uses. One is to reduce the number of variables or to find out the correlated variables. So here most of the variables are correlated, we know, but statistically we are establishing that. So first step is Cronbach's alpha, and for that we go to scale, reliability analysis, and the first construct is behavioral enablers, in which I have also clubbed it with the lean scope. So all these variables I have to put aside up to job involvement. So you can see here alpha, and we have to tick mark scale if item deleted, continue, and OK. So here we get for the variables selected. So seven variables we selected lean scope up to job involvement. The Cronbach's alpha is 0.746. So the construct or scale that we considered is statistically valid. And in case if some of the item is deleted, what will be the Cronbach's alpha? So 746 we have got, and that is the maximum we can get. So the scale is statistically valid. Next, we will go for okay. First, we'll input this value Cronbach alpha 0.76. From here, the output which we got 0.746, we'll put it here 0.746, and then we'll go for the factor analysis, dimension reduction, and here we'll select the variables up to job involvement. So these are the variables, and in descriptives, we need to select initial solution significance level determinant KMO value. Continue. In extraction, correlation matrix, the scree plot also we should select, and extraction based on eigenvalues or number of factors. So basically, we are not extracting any factors from this. We are just validating the correlation. So rotation, we'll choose Varimax rotation. Display factor score coefficient matrix. And here we can suppress values which are below zero point 0.3 to have a better view. Click OK, and we get the factor analysis now. So the correlation matrix, we can see that the determinant value is 0.142. So 0.142, which is greater than this value. So the correlation is statistically significant, and the KMO value is 0.69. So 0.69 is the KMO value. The P value is also less than 0.001. So we are satisfying the condition for statistical significance of the scale for correlation. And going ahead, we need to see the commonalities. So for the commonalities, we can see they should be greater than zero point 0.3. So here they are all greater than zero point 0.3. So we can copy this Excel worksheet, can paste it here, can paste it here, and then Then we can copy it from here and paste to our table. So here I will just commonalities, just for demonstration, paste values. So 0.46, 0.65. So same values are there. So next we need to get the eigenvalues and variation. So for eigenvalues, so total variance eigenvalues is are here. So 2, 1, then these are the variance. So similarly copy this as well. Then paste it here. From here we can copy both. These are the eigenvalues. Sorry, these are the eigenvalues and this is the variance. So paste it. So eigenvalues and variance. This for demonstration. I'll paste it here. So eigenvalues 2.8. Sorry, here we need to paste it. So 2.89, 2.89, 41.3, 41.3. So we have got all the values and they are all statistically significant. So this scale, the variables which we selected and the responses which we got, so statistical validity is established. So likewise, we can calculate the Cronbach alpha and determinant and all other values from factor analysis and scale reliability respectively. So for demonstration, I'll take one more. So we'll take last one, that is root cause. So these variables, number of variables are 8. So I'll select these variables. So first we'll find the Cronbach's alpha. Cronbach's alpha scale, reliability analysis. Put this all back. So from here to, so these 8 variables are the root causes. So we'll see the statistical validity, Cronbach's alpha. Cronbach's alpha which we got is 0.79. So put it here 0.79. So by factor analysis, we'll find all these other values. So now go for the factor analysis, dimension reduction, factor analysis, get all these things back, choose the root cause, choose the root cause variables, put it here, then the descriptives, all the boxes are already chosen, extraction, everything is fine. So click OK. So in factor analysis for the correlation matrix, the determinant is 0.02. So determinant is 0.02, which is greater than this value. So it is statistically valid. And KMO value is 0.651, 0.651. P value is zero point 0 less than 0.01. So accordingly, the commonalities, eigenvalues and variation, we'll get it from here. These are the commonalities, eigenvalues and variation. In copy and paste these values here. So I did this for the construct number 1 and construct number 6, that is the root cause and behavioral enablers. So similarly, we can do it for the disablers, organizational enablers, organizational disablers, and these constructs. So these are the results that we have got.